In this video, we will present CIDER, our concept-based interactive design recovery. For each project, CIDER will provide 3 different views plus a download tab. We will use Depends, a multi-language dependency extraction tool project, as an example for the demo. In the concept hierarchy graph, each node represents a cluster aggregated from one or more function groups, and each edge represents a uses relation between 2 clusters. Each cluster is named by filename if it only contains one file, or it will be named by the top 3 concepts extracted from filenames using TF-IDF. As we can see from this graph, the top level contains key data structures and utility files used by other functions in lower levels. The functions in the lower level use functions in the upper levels. The graph also marks clicks, a group of files that form a strongly connected graph. As we can see, the entity, object, generator cluster is marked with clique 32. It means this cluster contains a clique with 32 files. We can hover one node to highlight all incoming and outgoing edges and nodes. If we click one node, CIDER will display its detailed information on the left side of the page. It includes a clique list, a general description, top concepts in the cluster, and a function group list. To check the detail of a clique, we can click this button to open a dependency graph, showing all files in the clique. For a complex system like this, CIDER shrinks the graph to a height of 4 by default. We can expand or shrink the graph using the plus and minus controls to explore the recovered design structure at different levels of granularity. The Function Groups tab has 2 tables: the Concept Keyword table and the Function Group Cluster table. The Concept Keyword table lists all extracted concepts with their TF-IDF score, and the Function Group Cluster table lists all function groups associated with the labeled concepts. We can select concepts in the Concept Keyword table to filter related function groups in the cluster table and then select multiple function groups to see how they interact. For example, if we select FG number 2 and FG number 6, we can see FG number 6 as a subset of FG number 2. Next, the Facet Hierarchy tab lists all the concepts extracted from the source files, with related function groups of each concept. If we are interested in adding a new language to Depends, we can select concept C++ as a reference. All function groups related to C++ are displayed on the right side as a facet view, with function group information in the mid-table. If we are interested in how 2 concepts interact, we can select more concepts. Let us select Ruby. As we can see, most Ruby function groups are independent of C++ function groups, with one exception. The Ruby import lookup strategy is using C++ import lookup strategy, which is confirmed as a long-forgotten shortcut. In conclusion, our tool CIDER integrates multiple clustering techniques to extract a high-level design model in hierarchical function clustering. It presents the recovered architecture to a user as a tree of concepts. CIDER also detects and marks the clique anti-pattern during the clustering process for users to examine. Moreover, CIDER enables users to select concepts, recover partial designs accordingly for maintenance task reference.